Hello everyone, welcome to my YouTube channel. So here today we are going to be looking at our Cs110, which is the unit number 3. So unit 3 involves input and output devices. So the first thing that we get to discuss is what is data? What does data refer to? So data is just unprocessed information. Like for example, if you have 23 plus 17, the answer is equal to 40. But if you are pressing your numbers, your computer will read as a 2, you have entered a 3, you have entered a plus, you have entered a 1, you have entered a 7. The computer will not immediately say that this is 23 plus 17. So since you entered a 2, you enter a 3, it will assemble them and give you 23. So it means to say you said 23, then this plus 17 to give you some meaningful information, which is 40. Even the 23 together, when it is combined, it becomes what we call information like that. So data is more like it's just disorganized. So data is just unprocessed items or unprocessed. Let's look at our next question, which is our number 2. What is a command? So a command is a very simple thing. So we know to say if you command someone, you want someone to do something. So you can just say a command, this is an instruction to perform an action. So that is, in computer, that is what we call a command. For example, this might be a command, just opening an app. Looking at our third one, it says that a user response is. So we know what a response is. It means to say you have you giving feedback. So user response is just the person giving feedback. So a user response among these options is let's say system generated data, no. Instruction from CPU, no. So user, remember, user response, meaning to say you are responding as a user. So it is input given by the user after a message. So let's say you receive a message or an instruction. Let's say to say you are told to shut, maybe some of you have seen this, to say external application down. You are given options such as close or wait. Then whatever you will choose, many of you choose to wait like that. So that means to say that is a when you press on a wait, that means to say it's a user it is an where is it? It is a user response. What do you do after you see a message or a prompt? A prompt can be a message or an instruction like that. You can choose to close. That is still a user response. Let's look at our fourth question. Which is not a type of output? So remember, output is what you can see. So text, you are able to see the text in your eyes. So the example of the text is, even this question is a text. So that is an output. As long as you are able, it is able to reflect back to you. That means to say it is a text. Oh, sorry. Yes, it is an output. If you look at graphics are just, I would say, attractive images like that. So let's say we have a drawing of a person, then that simply means to say, now in detail, that simply means to say that those are graphics. We will dive deeper into the graphics as we look at further questions. When we look at audio is more like we should have a speaker that is able to give you back sound. Now, as long as you're receiving sound, that simply means to say that is an output because it's giving feedback to you. Then storage is not an output device. So storage is not an output device. When we look at our fifth question, so when we look at output, it depends on the hardware. So under the hardware, we could have things such as speakers, the tangible things. So if you look at a speaker, it is able to produce what we call, it is able to produce an output. So we might have speakers, we might have printers. So these are output devices. A printer will produce a paper, a speaker will produce sound. It is not only hardware but also software. So the software is also important. The software that we might look at, we might be looking at even application software, such as when you're looking at Microsoft Word. So Microsoft Word is a typing thing, and it produces Word, like it just produces words, or rather it produces text. So it also output also depends on the software. The other software that you might have is media. When we look at media, there are two things that we are looking at. We are looking at either audio, we might be looking at audio, or we might be looking at video. So it can be audio or video. Then so those are the examples there. Then we are also user needs. So the user also influences what type of an output device they are going to be using. Like for example, if you're looking at a user who is a student, students might want printed notes. So users will influence what type of output they need or require. So the answer there is C, like that. Then when we look at our 6, which one is an example of text output? When we look at our number 6, which one is an example of text output? So text, things that you can see as being typed. So a video is not typed. Music, that's sound. So video has to do with the visuals, or rather images. Animations is a type of video where we use cartoons, I would say. So the best answer here is email. So email is an example. When they send you an email, they might say hello, which is not common, or they might send you something that has to do with a business opportunity, or when you apply for a school, they will send you an email, and an email is a text. They will say, hello, you have qualified for sponsorship, or you have qualified to come at a prestigious university, and all that. So the answer for this one is email. When we look at our 7, graphics include. For example, this is an example of graphics. So as you can see, this bright image that is being made, that is being drawn using a digital pen, which might be a stylus pen, this pen, which is equipped to write on tablets or smartphones, like the one that I'm currently using. So just as you saw, those were images. So graphics will involve, sometimes a chart might be created and images like that. So you might have something like that and all that. Then that simply means to say you are looking at what we call graphics. So graphics combine charts. They can have charts, they can have images like that. Question 8, audio output includes. So audio output has to do with music. Is there any other option? No. So audio output has to do with sound. Audio is sound. Let's move on without wasting time there. Video output. So which one involves video output? It's movies. Then when we look at our number 10, data becomes useful after. So data only becomes useful after it is processed. So just as I said, if you are doing a mathematical calculation, you enter a 2, a 3, you enter a plus, you enter a 1, a 7. That's how data is read. But for it to carry some meaningful information, it has to be processed, so that the computer can read that 23 plus the 17 should be equal to 40. Otherwise, the computer, when it's entering as data, it will just be 2, a 3, a plus, a 1, a 7. like that. So data has to first be processed for it to carry some meaningful information or communication. When we look at our 11, we have a manual input device requires. So when you are looking at a manual input device, the word manual itself simply talks about the fact that you have to enter using your human hands. So a manual input device, the example that I can give is a keyboard. You have to press certain buttons, so this requires direct human input. Then number 12, which is a typing input device. So this one, very simple, without wasting time, we have the answer is a keyboard. Number 13, function keys are labeled. So these function keys are from F1 to F12 without any struggles. So as you can see, these are the input, these are the top row. This row is what we call the function keys. So these are the function keys. Just this row, this top row. So these F1, F2 like that. Until F12 like that. So we have the F1 through until F12. So the function keys are special keys in the fact that they help in providing shortcuts. So like for example, if you press on let's say your F1 is an option, a shortcut to help. Let's say if you press on F2 is important for renaming something. So when you want to rename, you are going to use your F2 key like that. So there are a lot. If you want, let's say F3 is for searching. So these provide shortcuts. You don't have to go somewhere, just press on F1 for help, F3 to search something. When you have F2, you have rename like that. Then toggle keys, on the other hand, these are keys that are used to turn on and off features. Like for example, if let's say you are typing to say the boy is cooking. So now when you press on one of the keys which we call caps lock, many of you are conversant with the caps lock. When you press on it, everything will be capitalized. You are going to be writing the boy is cooking. So those are toggle keys. The other toggle keys, so we have caps lock is a toggle key. We might have what we call num lock. So num lock, just as the word entails, num, which means number. So when we are looking at numbers, where let's say for example you have a number such as a number, you know that the keyboard sometimes might have a number and a letter, but when you don't know which one is going to pop up, so when you press on num lock like that, you press on num lock, you will be able to just be choosing numbers. If it's 1, 2, 3, 4, 5 like that, that means to say when you press on a number such as there is a 5 but there is an arrow, okay, let's say it is another letter like our symbol Q like that, the one that is going to come is a 5 because you have put the num lock. So toggle keys are those keys that turn on and off features. If let's say the caps lock is on, that means to say it will be capital letters throughout. So if you look at the keyboard, if we go here, this is an example of a toggle key. When you just press here, then when you press A, it will come out as capital A. Whatever letter you will press, it will be a capital letter. So that's the working of toggle keys. Now let's move on to our next. So before we move on, like as you can see on numbers, there is 1, there's 2, there's 3, but on top there is hash, there is like a symbol for @. By using a toggle key such as numlock, it simply means to say when you press on 4, instead of you receiving the dollar symbol, it will come out as a 4. It will come up as a pure number like that. Let's move on. So don't forget to navigate is to move. So like for example, this thing that you see here is what we call a cursor. Many of you have seen it on the laptop. So a cursor, so to navigate, navigation keys, these just move the cursor. So that is basically what navigation's keys do. Is it navigation keys? So one of the examples, so if you look at your keyboard, which looks like this, one of the examples of navigation keys are these directions here. So we could have this navigation key up, this direction, or down like that. So these are navigation keys. Let's move on to our next question. So 17 says that a keyboard shortcuts. So keyboard shortcuts speed up what we call commands. Like for example, like let's say for example, you are required to make a command. Remember, a command is just an instruction to perform a task like that. Now let's say you want to copy everything. Let's say you are moving from here, you will start to drag like that. You will start to drag until you manage to copy each and everything that is down there, and there are a lot of things. So therefore, so you can continue like that. But what the other way does is that it also now increases the rate of doing work in such a way that, let's say if this is a computer, you go here, you go on select all. So on the computer you will say something like control plus A, meaning to say control times choose all. In other words, that is what you can think of. So when you do it in that manner, you will find that every text will be copied exactly the way it is. Due to that, keyboard shortcuts tends to speed up commands. So that is an example for that. 18, a pointing device is used for. So remember, this is a pointing device. Let's look at our A, print documents, B, select items on screen, store data, that. So without wasting time, the answer for this one is B. So it is to select items on screen. So whatever is on the screen, when you select those things, then that is what we call a pointing device. So it is used, or rather it is used to select items on the screen. So going back to our same usual example that we had, let's imagine that you want it to point on the head like that. So that is the function of the pointing devices. Then our 19 says that a pointer is, so when we look at our pointer, a pointer is what we call a software icon. So software can be a system software which the app comes with, or the application software. The same for example, so like for example, if you want to go to the next app like this, you have to move your cursor. So your cursor is an example of, so remember, all those images that you are seeing, all those apps, the Play Store, the WhatsApp, they are all icons. So icons which are images that will show you what you are pressing on. If you press on this, you're going to go to, let's say you're going to go to WhatsApp. If you press on one, you will go to WhatsApp. If you press on another, you will go to YouTube. So all those images that you see there, that is what we call an icon. So now likewise, even the pointer, which is the cursor in that case, does so. It is an example rather of a software icon. When we look at our 20, a mouse is number one, it is an input device. It is also, not only is it an input device, but it is also a pointing device like that. So our C option is our answer for that one. Then when we look at our 21, optic mice uses what we call not just sensors but light sensors. So it uses light to sense the change in the texture of where it is put. Like for example, if you have put it here, so if you have put it there, then this is your mouse. As it moves, the mouse is able to detect a change, because not all the surfaces of the material are the same. So as you move the mouse over the surface, it is able to detect and produce more like this sensitivity. So down here there is some light. So let's say we have something like this. So this is the mouse. So down here there is the light source, more like a light detecting source. So it is able to detect just the change in the light as it is passing over a surface. Then that movement will be translated into the motion. It will cause, let's say if we have the cursor there, as you are using your if this is what we have. So let's say this is the mouse that we have for this problem. Let's say this is the mouse here, this one. So as it moves like that, it is able to let's imagine this is the screen of the computer. So whatever movements the mouse makes, even the cursor will be able to move. So as you put your mouse on this image, let's imagine this is a 3D image like that, a 3D image like that, yes, like that. So as everything goes, you will find that this movement will be converted into the movement of the cursor there. So when we are looking at the optical, it uses light. Then the laser mouse, this one uses laser sensors on the other hand, but operates on the same scale. But it's only that the lasers have got much more penetrating power in terms of the objects on which they have been placed. That's why the laser mouse are better than the optical mouse. So this is the light mouse. So this is the light mouse. So this is the source of light like that. So as you pass this source of light over the surface, the mouse will be able to cause a movement of the cursor on the screen, just as I displayed last time. So we have the light mouse like that, it uses light. Then we have so as it moves on the surface, it is able to create that movement, and this will be exactly the same movement that the cursor will be moving on the screen. So as you can see, as this is being moved, that will be the movement. As the mouse is being moved in this direction like that on the screen, this is what will be displayed. So when we look at this other one, we have a touch mouse. This one, just as the name entails, it recognizes a touch. So touch mouse detects finger gestures instead of relying on buttons only. So finger gestures are just how you are more like handling, what are you doing. We shall go further into details looking at the other questions. So that looking at our 24, an ergonomic mouse is designed to. So before we answer this question, remember what ergonomic means. So ergonomic simply means designed for human comfort and health. So anything that is designed for human comfort, as long as it is designed for human comfort and effort, that's for human comfort and health, is termed as ergonomic. So ergonomic mouses, those that improve comfort and health, one of the more like things that develop constantly using hardware is what we call repetitive strain injury, which is the RSI. So if someone, let's say, presses the keyboard for a very long time, you will find that that person will be experiencing some form of injury. So to prevent that, they make ergonomic mouse, which is designed to boost comfort and health, to prevent, let's say, those fingers from hurting. So the answer for this one is it reduces strain injury. Injuries that develop as you constantly use your devices. Number 25, a touchpad is common in. Just to add on, so on the optic mice, the type of light that we use is LED, which is the light emitting diode, in case they finish. So this is LED light. So this LED light is the light emitting diode, like that. Then when we look at this other one, the laser one just use laser beams. So this is the thing that uses laser beams. So these laser beams are in form of infrared, which is the part of the spectrum that you cannot see. So the other question that is asking for the touchpad, it is common in laptops. So as you can see, this is the touchpad. So this is the touchpad, like that. So this area is the touchpad. It is commonly made on the laptop. So the answer there is a laptop, like that. When we look at our 26, a touchpad, what does it detect? So this detects the motion and the pressure, the amount of pressure that you apply. So because your finger does not have to leave that area, remember, pressure is the force per unit area. So pressure is the force per unit area. So this place is or point is experiencing pressure, so that it is able to detect the motion as you move on the screen. So this one acts as like a mouse. So as you move this point, the mouse will be able to move like that. So it will be able to move like that. 27, we have a gesture is. So a gesture is just a finger motion on screen. So how is your motion? How is the motion? Like, let's say if you are looking at the phone like that, how is your motion? So this movement is or rather is used to control a device. So through such gestures, you will find that these will be used to control a device. So this is an example of a gesture like that. Then let's look at our 28. So a tap gesture is used. So tapping is used for. So this is very, very simple. We have selecting items. So as you tap, the tap gesture is used for selecting items. Number 29. So if we are looking at pinching, so pinching a screen, so this is how it works. Let's say this is your image, you want to pinch the image. So as you pinch like that, it reduces the size like that. So pinching is zooming out. So zooming out meaning to say you have reduced the size. Stretching, on the other hand, involves you doing that, meaning to say stretching is zooming in, meaning to say there is an increase. Zooming in, increase. Zooming out, there is a reduction. So this is the pinching action. So as you pinch like that, it means to say if you have an image, it's experiencing a pressure on both sides like that, that means to say it will reduce. But when you stretch the image, it will be something like this, where it will be put up and down in this direction, meaning to say it will increase in size like that. So stretching is zooming in, pinching is zooming out, meaning to say there is a reduction in the size. So for touch screens, these allow interactions by using fingers and stylus. So a stylus is just a pen, as I showed you, a digital pen like one that I'm using to write. This is a stylus like that.